Hey everybody, greetings and welcome. We're taking a look at page 339. We were talking about solving quadratic equations by graphing. Now 23 is a very good conceptual problem here where I've got a quadratic equation, right? It's an equation because it has an equal sign and it's equal to a number. So you could technically solve that using some other techniques, but we're talking about the graphing approach. So the idea would have been that you would have rewritten this as y equals x squared plus 8x plus 16. You would have figured out all sorts of stats about this, but they already did that for you because they had graphed it for you. What? And when looking at this graph, what point was I interested in that also happened to represent the solution?
Is it 8x plus 16, that's 6?
Thank you.
You're welcome.
Good catch, Jacob.
Good catch, good catch. So what point on this graph is the helpful one?
The vertex.
Well, actually, in this case, coincidentally, it is the vertex, although that's not normally what we'd look for. Whatever the x-intercept is, right? Since I replaced 0 with y, anytime y is 0 on this graph would represent the solution x to this equation. So notice that y is 0 on the x-axis. Flex those muscles, and you find out that that's right here. There's only one x-intercept. There can be more for quadratics. So what is the x-intercept here? -4 comma 0, which means for the original equation, x equals -4 would have been your solution. And just for funsies, let's do a check. Check for funsies, gonna have fun. Gonna be great, oh yeah, let's check.
Miley Cyrus. I don't know if you're watching this video.
Miley Cyrus is watching my video right now?
If she's watching,
She's gonna steal my song? Is that what she's gonna do? That's my song. I just made that right there. On the spot too. I'm an incredible musician, lyricist. Let's see, 16 minus 32 is -16 plus 16. That equals 0. Yeah, so it checks out. Check it.
Check it, yeah.
So, all right, so that was kind of like the overarching concept of solving a quadratic equation by graphing, right? You replace it with y, you graph it, you find the x-intercept. That was your solution, all right? So, now let's talk about 27, in which I've got, oh, they actually use g of x instead of f of x. That's great. They're branching out using different letters for the function name. I'll like it a lot.
Oh, I got it wrong because I didn't know it.
Well, then let's learn right now. So this is a quadratic function. It's a function because I have two variables, right? G of x is the same as if I called that y, just so you know. It's just a different notation, a different way to write it. So I've got y equals x squared minus 9x plus 9. In this quadratic function, what are a, b, and c equal to? I like it. I like it a lot. So let's now start finding our significant points. So let's find the vertex, which we could do using the formula h equals -b over 2a, right? Was our little formula. So you gentlemen following along, writing this down, of course. I'm glad. Yup. H equals negative of -9 over 2 times 1. So that's 9/2. Which, by the way, is 4.5 if you wanted a decimal approximation of it. So 9/2 is h. To find k, the y-coordinate of our center, we were told to plug in h into our function. So k is going to equal g of h in this case, not f of h, since my function's name is G for George. So k, my y-coordinate will be 9/2 squared minus 9 times 9/2 plus 9. That's a lot of 9s. Well, just keep up as best you can. 9/2 all squared is 81/4 minus 81/2.
I got this. I just don't. Oops.
All right, we'll keep going.
Because 9 over 2 is 4.5. I just kept 9 over 2 and I got scared.
So to combine these, I'll need a common denominator. Multiply this by 2 over 2, this one by 4 over 4. If you need practice with adding and subtracting fractions, check out Khan Academy. Search for adding fractions. I'll help you out. Represent. 81 fourths minus 162 fourths plus 9 times 4 is 36 fourths. Yikes. So equals 81 minus 162 is negative 81. Spending a lot of time on this fraction, but that's okay. Equals, let's see, 81 and 36. I would subtract them because their signs are different. Wait, I'm trying to do math in my head and I'm scared. Is that negative 45 fourths?
I have a question.
What's your question?
Why couldn't we just make it like 4.5 instead of 9?
Negative 81.
Because boo, decimals.
But decimals would be so much more easy to work with.
Maybe.
What makes that a negative 81?
81 minus 162 became negative 81. 162 happens to be exactly double that. Let's see, 45 fourths. 4 goes into 45 11 times. So is it a negative 11.25? So there's a decimal version of that for our decimal fans. So our vertex is 4.5 comma negative 11.25, right? So there's our vertex. How do I find my x-intercepts? Does anyone remember? Well, what you do, the x-intercepts occur when y is 0. So plug 0 in for this, set it equal to 0. So I'm going to say set g of x equal to 0, right? And solve it. So in this case, that's x squared, what is that, minus 9x plus 9 equals 0. So to solve that, are there any factors of 9 that add to be 9? Really? No, there aren't. That means it's going to have to be a quick quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So let's quickly plug this in and evaluate. So x equals negative of negative 9. So that's just, I'm just going to write positive 9 plus or minus the square root of negative 9 all squared minus 4 times 1 times 9 all over 2 times 1. All right, equals 9 plus or minus, cruising right along.
Yeah, I know you are.
81 minus 36 over 2 equals 9 plus or minus square root of, is that 45 again? 45 halves? No, it's root 45. And actually, I could break that down. But these are going to be crazy decimals anyway, so I might as well just figure these out. So x is approximately, I'll do 9 plus root 45, all divided by 2. So I can't just plug that in the calculator. 9 plus root 45 divide 2. That would be wrong. I need to parenthesize the numerator. 9 plus root 45, close parentheses, divide by 2. And I get x is about 7.85 for one of those. And the other one, hit second enter and change that into a minus sign here. Let me just show you if I can. Yeah, so when I plug those in, 9 plus root 45, all divided by 2, so that's why I had to have the double parentheses there. And what I did here, I hit second button and enter, which will pull up the entry, and it'll actually re-enter. Oh, darn it. It re-enters the previous line. Since I just did it twice, it entered 2 lines before. And then I would have gone over and changed that to a minus sign. That's a shame. Now I have to enter it twice. 9 minus square root 45, close, div 2. And I get 1.15, we'll call it. 1.15. So, what do these represent? These are not a single ordered pair. These are 2 ordered pairs. This is like an orchard of pairs. What would you call multiple pair trees? I don't know. Is that an orchard still? A grove of oranges, right? I don't know. So those are my x-intercepts. Y-intercepts. Question, how do I find those?
9. Just like that. It's C.
Yeah, the y-intercept, there's only one of them, and it's just
It's just the
0 comma c, right? Or just whatever old c is. So 0 comma 9 is the y-intercept. Let's see, question, which way does this open? Up, because 1 is greater than 0, right?
or
The value of
smiling,
a.
you mean?
It's smiling. And is it a stretch, smoosh? What does the shape of this look like? Well, a equals 1, so it's regular shaped. Regular, right? So let me graph this. Let me actually open up a nice little, open up some Geometria Sketchpad. Let's see, it's opening. Open Sesame. Let's see, make a nice grid here, grid form. I'll do a square grid, why not? Bam, there we go. That's what I'm talking about. So question, where should I focus my grid? Let's see, where was my vertex?
You should put it on perfect regular.
Over 4.5 and then down to 11.5? A quarter, sorry? Okay, and it's opening up, it's regularly shaped. What were my x-intercepts? Okay, so yeah, so I'll just kind of focus right around here. Actually, maybe I can even, because I only have to go down to 11.25, right? Something like, let's see, so let me, snapshot. So yeah, you want to plan your graph in advance if possible. So let's plot these points. Now, let's see, over 4.25, 4.5, down 11.25. Looks like it'd be right about there, right?
Yes.
The x-intercepts were at 7 and what? 0.2, 1, 3, what was it?
8, 5.
0.8, okay, so there's about 7.8. And then 1.13 was it or something?
1, 5.
Okay, somewhere, actually maybe even closer there.
So it'd be right.
And it's a regularly shaped parabola. Oh, I didn't give enough room to fit my y-intercept. I should have planned ahead.
I don't get the axis of symmetry.
Well, the axis of symmetry always passes through the vertex. And the idea is that this point is the same distance as this point to the axis of symmetry. And that's true for every point on the parabola. Now guys, check this out. It turns out for a regularly shaped parabola that you can, ready? You can find the slopes of the parabola. Check this out, bonus content right here. Slopes. All right? And that the slopes of a regular shaped parabola is up 1 over 1, up 3 over 1, and up 5 over 1. Where they're consecutive odd numbers, 1, 3, 5. So the next point would be up 7 over 1, and then up 9 over 1, and then up 11 over 1. These are what I'm referring to as slopes. So let me show you what I mean by that. Where I can actually find from my vertex, I'll go up 1, which would bring me to negative 10.25, and over 1, which would bring me to 5.5, and there would be a point. And then I could go up 3, so up 1, 2, 3, so it looks like that would bring me up to negative 7.25, and then over 1, right, so that would bring me over to 6.5. All right, so up 1 over 1, up 3 over 1, and then I'd go up 5. What? 1, 2, 3, 4, 5. Is that a total of 5? I think so. And then I'd go, did I go up too high? 1, 2, 3, 4. Yep, shame on me. Wah, wah, wah. Aha, that's one way to do it. Thanks for having my back, friends. And then I'd go over 1, and that would be at 7.5. And then you can see that I get more points as a result of doing that. And not only that, so those ones I kind of had to work for, I also can get the freebie points, right? So this is 1 unit away. So 1 unit away over here, there's going to be another point mirroring it, right? So mirror. This was 2 units away. So 2 units away this way. Mirror it. 3 units away. So
Really?
1, 2, 3, 3 units away over there. And now I can graph this, and look how beautiful this is. It's getting steeper and steeper, faster and faster. That doesn't come down to a sharp V cusp. It's technically a smooth transition right there. But that's what it would look like. Thing of beauty. So that one's tough because it had all the decimals and fractions, but that's why I figured I'd do this one out for you guys. So thanks for watching, internet friends. Bye-bye.